Hello and welcome everyone to my channel Code with Ease. So as part of the binary search series that we are doing, today we have come up with another question which is called how to find the first and last position of an element in a sorted array. So for those of you who are new to the channel, here's a brief introduction on the channel. Hi, here's a brief introduction for the ones who are new to the channel. The objective of Code with Ease is to make problem solving in programming simpler. If you are someone who wants to become a great developer and wants to level up their skills, data structures and algorithms is indispensable and you need to form a solid foundation of that. And this is exactly where we come in. Because we post topic-wise video explanations in Java on various coding interview questions that can not only help to crack the coding interview, but also help to improve and refine the problem-solving abilities as a developer. And finally, here is the USP of our channel. We code every solution live, we do not copy paste code snippets. We start off by clearly defining the problem statement, the given inputs, the required output, time and space complexities. We also then discuss the brute force way of solving any question without jumping on to the solution and then gradually move on to the optimal solution. We try to use online whiteboarding wherever applicable to explain the approach and the concepts. So that is all about us. So if you guys also want to be a part of this journey, do support us by subscribing to the channel. So with that, now let's get back to the question. So let's come back to the problem statement. So we are given an array of integers which is sorted in non-decreasing order, or it's in ascending order, and we need to find out the start and the end position of a given target value. If the target is not found, we have to return an array of -1 and -1, and you must write the algorithm with order of log n runtime complexity. So a lot of hints are given already in the question which suggests that binary search is the algorithm that needs to be applied, because first of all it talks about it is already in a sorted order, and secondly it talks about that the algorithm has to be written in log n complexity. So it's a no-brainer that we have to use a binary search algorithm. So let's walk through this example. This is the elements that we are given and the target is fine, and the target is 8. We have to find out what is the first occurrence of 8, which is index 3, and the last occurrence of 8 is index 4. And in this case, in the second example, 6 is not even there, so we have to return -1 and -1. So that's about this question. We have to see how to apply binary search to this. And so just one point to note that we have to return the start index and the end index. So now let's move to the whiteboard to understand the approach for this question. So into the whiteboard, this is the array that we have taken and this is the target element, and the output is going to be 3 and 4 because that is the index 0, 1, 2, 3 and 4. So what should be the approach for solving this question? And also we have to think, when do we need to return -1 and -1? That is the edge case that we have to handle. If you guys are new to the binary search algorithm, I would highly recommend to check out the playlist of binary search algorithm in the description, in which we have covered everything from scratch, and we are doing now the questions also one by one. So do please check it out, how the algorithm works and everything about the algorithm, and then you can come back to this question. So in case of binary search, what happens is there is always a 3 pointers or 3 elements. One is the starting element, another is the ending element, and the mid pointer. And with the mid only, we check whether the given target value, is it equal to mid, is it greater than mid, or is it lesser than mid. These 3 conditions only, that's it. So in this case also there can be these 3 conditions only, right? So the element that we find out, that ARR of mid, we'll find out the mid anyway. It can be either equal to the target that we have, or it can be less than the target, or it can be greater than the target. Now we have to take a call in what conditions, what are we going to do? What are the things that we have to do in every condition? Okay, let's talk about if it is already equal to target. Fine. So let's say we are over here, or maybe we are over here. What we have to find out is we have to divide this into 2 parts. In one go, we won't be able to find out both the first and the last occurrence together in one single traversal. We have to do it in 2 parts. First, we'll figure out what is the first occurrence, and then we'll figure out what is the last occurrence. One more thing I want to point out regarding this -1 is, let's say in the first occurrence only, that element is not found. Like we have a target called 6 and that element itself is not there. So this first occurrence, whatever this logic we will have, in that only we get nothing, like the element is not found. If that's the case, then what we should do is, we need not even run the logic for the last occurrence. If the element itself is not present, there is nothing called last occurrence also. So if the first occurrence itself returns as empty, null or whatever, if it returns that, then we are going to return -1 and -1 and exit over there. This is one thing we have to take into consideration. So that is about the edge case. Now we'll come to the happy flow. So let's say if the ARR of mid is equal to the target, we found an element which is exactly equal to the target. Now, it might happen that it is the first occurrence of the element. We are only talking of the first occurrence now. Forget about the last occurrence. So, it might be possible that it is the element itself. So, we need to store this. So, in the answer, we'll have an answer variable and we'll store this. Because it might be possible that that is only itself the first occurrence of the element. Next, less than target. If an element is lesser than target. So, we have a target 8 and we are at 5. What do we need to do? We have to go ahead. So, our start pointer should be equal to mid plus 1. Again, if it is greater than target means, okay, one more thing I just missed. Apart from storing the answer, we also have to look for further left, because let's say if the target, it is equal to target, let's say I'm over here. So 8, I can think maybe it is the first occurrence, but what if there is another 8 before the current 8? That is why I have to go to the left side whenever I am finding the mid is equal to target. So what I'll do is, I'll do end equal to mid minus 1. Apart from storing the answer, then I'll go left side just in the search of any other first occurrence. Okay, coming back to this. Now, if it is lesser than this, start equal to mid plus 1 straight away, nothing else to do. If it is greater than target, again, if I'm at 10, what do I need to do? Again, I have to go left side. So, again, there also I have to do this end equal to mid minus 1. So, only in case of this, when it is exactly equal to target, is when we have to store this answer equal to mid and then just return this. And of course, initially we can set the answer as -1, so that if it is not found by default, we are going to return it as -1. That is all. So this is what we are going to do in the first occurrence. Now talking of the last occurrence. Same three conditions. ARR of mid is equal to target, or this ARR of mid is greater than target, or it is lesser than target. So if it is equal to target and we want the last occurrence, same thing, it also can be the potential answer. So what I need to do, I'll store this. Now since I want the last occurrence, I have to do reverse. I have to go right side. So I will do start equal to mid plus 1 in the search of any other element to the further right of this. If it is greater than target, again, I am at 10. I am already, if I am at 10 and 10 is greater than 8, so I have to go left side. So that logic is going to be still the same. So end equal to mid minus 1. And if it is lesser than target also, it's the same thing. Start equal to mid plus 1. That's it. So in one chunk of the logic, we are going to find out the first occurrence and store it. And in the second chunk of the logic, we are going to get the last occurrence and then we are again going to store it. And at the end, we just have to return an array of that index. This is the first index and the last index, if at all it is found. Otherwise, we have to return -1 and -2. That's the approach for this. Let's do a dry run. Starting with the dry run. So what is the mid element over here is this. Target is 8. So mid is again, this is lesser than 8. So by the way, these are the start and the end pointers, or the low and the high, whatever you may call it. So because it is lesser, so start should be mid plus 1. So now start should be over here. What is going to be the mid over here? Mid will be over here. Now this is exactly equal to the target that we are looking for. So now we'll store this. So this index of answer is going to be stored as 4. And we are going to go leftwards because we need the first occurrence. So end is going to be mid minus 1. So now end will be over here and mid will also be over here. Again, we found the element which is equal to target. Now we'll update our index from 4, we'll make it to 3. Again, we'll go leftwards. So end will be mid minus 1. So end will come over here and the loop will break because end has the S is ahead of end. So with that first occurrence, we got 3 index. So this is the first index that we got. Next is going to be for the last occurrence. So I'll again write this array. So what is the midpoint over here? Again, same thing. This is going to be the mid. This is lesser. So it will be start will be mid plus 1. So start will come over here. This is going to be the new mid. Again, same thing. In this case, we found the answer which is equal to target. So we are going to store this. So we will say answer of last occurrence is going to be index number 4. Now, since I want something which is the last occurrence, I'll go rightwards. So now the start will be mid plus 1. Start will come over here. Now this element, again, this is a mid also over here. 10 is now greater than the target that we're looking for. Because it is like we said, if it is greater than the target that we are looking for, then we have to go left side. So now end will be mid -1. So end will come over here, loop will break. What do we have with us remaining? We have this answer left, which is the 4 index number 4, and that is going to be our last index. So in this way, we got our first occurrence index and we also got the index of the last occurrence. So now let's see how to write the code for this. So we'll also define an answer array, which is going to be of size 2. One more thing which you have to take care of is the scenario where we have to return -1 and -1. So in the event an element is not found in the first occurrence only, then there is no point in checking for the last occurrence. So by default, we are going to initialize the values of this to -1. So we'll just set this to -1 before. So with that, now we'll start with the loop to find the first occurrence. So we'll have the while loop and we'll compute the mid. We'll check whether the nums of mid is equal to the target that we are looking for. If it is, then we are going to set this at the first index, at the 0th index, to the index that is the mid. And we have to look, so we'll do n equal to mid -1. Else if it is smaller than target, then we have to anyway look towards the right. So start, not start, my bad. There's going to be high and low. Low is equal to mid +1. Else high is going to be mid -1. So that's all the logic for this. In this, we are going to find out the first occurrence of the element and store it in the array. Now, before we move to find out the last occurrence of the element, we have to do this check that, let's say if this check is never true, that the target element is not found at all throughout the array, then obviously this answer of 0 will not be set to the mid. So it will remain as -1 only, -1, which is not a legitimate index. So we'll just do this quickly, this check over here, that if answer of 0 is equal to -1 still, means this element is not found. So we'll return the array itself. We are not going to do the check for the last occurrence. Otherwise, we will do the check. So I'll just copy this snippet again and we'll reinitialize the low and high pointers. Same thing, just that this line is going to change. That will be answer of 0 will change to answer of 1. And in this case, since we're doing it for the last occurrence, so we have to go forward. So it is going to be low equal to mid +1. That's it. Everything else is going to remain as is. And finally, at the end, we just have to return the answer. Yeah, that's all about this. Let's run this. We'll submit the code. Okay, so this is all about this question called how to find the first and the last position of an element in a sorted array. Hope you guys have enjoyed the session so far, and I would highly recommend to watch the other videos as part of the binary search series, which I am going to link it up in the description and also going to link up above. Do let us know in the comments below if you guys have any questions or doubts, or you want to share any feedback on this video. If you have enjoyed the session so far, do hit the like button so that this can reach out to many more people. And if it does, it just gives us enough motivation to put out more such content. Also, if you are looking forward to more videos like this, please don't forget to subscribe to the channel and press the bell icon next to the subscribe button to never miss an update on our upcoming videos. Thank you so much for watching.